Hi everyone. We're going to talk about how difficult it is to reduce E, the margin of error. Now don't say it's because stats class is hard. It's not. And it really comes down to this formula here. This is our formula for the required sample size if you want a certain margin of error E, given a confidence level, like 95%, or in this case, 99%. Now, take a look here. In example 3, we needed a sample size of 148 to get a confidence interval, a CI for mu, the population mean amount of ice cream per carton, that looks like this, where when we eventually construct the CI, the confidence interval, it's a 99% confidence interval, by the way. If you take a sample of 148 cartons of ice cream, and you do your statistical analysis, you find the sample mean, all right, you find the sample mean, then when you construct your confidence interval, it's going to look like this, where the sample mean is, of course, at the center of your confidence interval for mu, whether it's 99% or something else, and the margin of error is the half width of this interval. Now remember, in the previous example, we were looking for a margin of error of half a fluid ounce. So in order to get this kind of confidence interval, we needed to sample about 148 cartons of ice cream. Our sample size, little n, required, had to be at least 148. If it's bigger than 48, then you'll shrink the margin of error even more. But remember our interpretation from example 3. We need to randomly sample 148 cartons of ice cream to be 99% confident that the eventual sample mean, whatever sample mean we get for those 148 cartons, will be within about half of a fluid ounce, 0.5 fluid ounces, of the true population mean amount of ice cream per carton. Okay, so the required sample size is 148. Now, what if your CEO for this ice cream company, it could be Ben, maybe, it could be Jerry, but let's say, or someone else, let's say the CEO for this company says, hey, for this study, I'd like to have a smaller, more precise confidence interval. Why don't you cut the margin of error in half? Now, if your CEO just says that off the cuff, then your CEO may not have taken statistics or may not have done well in statistics because it's harder to reduce the margin of error than it looks. Even at the same confidence level, here, 99%, what sample size will we need to cut the margin of error, E, in half, down from 0.5 fluid ounces to 0.25 fluid ounces. That is from half a fluid ounce to a quarter of a fluid ounce. Well, here's a clue. When you take this formula for the required sample size, little n, let's actually bring in the squares here, all right? A mathematician or a physicist might say that there's an inverse square relationship. Don't freak out about that, but there's an inverse square relationship between n, the required sample size, and E, the desired margin of error. So if you want to cut the margin of error in half, some people might guess, oh, do you just double the sample size to maybe about 300? No. In order to cut the margin of error in half, it's not enough to double the sample size. You have to quadruple it. You have to multiply it not by 2, but by 4 because of this inverse square relationship. Well, this is right here. Right. If you want the new margin of error to be half the old margin of error, like in this example over here, from 0.5 to 0.25 fluid ounces, the sample size n would have to be multiplied not by 2, but by about 4. Granted, there are rounding issues over here. So in example 3, given the same specifications, if you wanted the margin of error to be cut in half down to 0.25 fluid ounces, your sample size would have to grow from 148 up to 589, which is about 4 times as large as before. If you want the new margin of error to be 1/4 of the old margin of error, then the sample size, little n that's required, it's not multiplied by 4, it's multiplied by the square of 4, 16. If you want to reduce the margin of error down to 1/10, you need 100 times the sample size. So it's much harder to reduce the sample size than you might think. So if your boss says, hey, why don't you just cut the margin of error in half? Your sample size has to grow. It's got to be multiplied by about a factor of 4. Warning, it is more difficult to reduce the margin of error E than one might think. The sample size has to grow a lot. Next time, we'll talk about another issue with this formula. It's a key structural issue. What happens if we don't know a value for sigma? That's a big question. I'll address it next.